Hello, and thank you for taking the time to review my reflection. My name is Zandri Keys, and this recording forms the audio component of my individual assessment for the Operational Effectiveness course. In this reflection, I'll share how the syndicate assignment expanded my understanding of operations strategy within life healthcare, what I learned from collaborating with multidisciplinary teams, and how these insights have shaped my personal development and future career direction. Our syndicate project focused on Live Wilgewevel and Live Nsambeni hospitals, specifically evaluating the engineering and maintenance functions. The core objective was to analyze engineering performance as a determinant of hospital reliability, patient safety, and operational efficiency. My primary contributions including analyzing workforce capability, assessing technical staffing models, and applying operational frameworks such as Lean, the theory of constraints, life cycle costing, queuing theory, reliability-centered maintenance, and order qualifiers and order winners. One of the most significant insights was recognizing how operational delays in engineering are not isolated technical issues. They influence the entire clinical value chain. For example, a delay in repairing oxygen supply points initially appeared minor, but the impact cascaded through theatre scheduling, ICU bed allocation, patient transfers, and clinician workload. This demonstrated a real-world example of the butterfly effect. In healthcare operations, a small failure produces disappropriate system-wide consequences. A major challenge we faced was integrating perspectives across technical, HR, and clinical domains. Each discipline used different terms to describe similar problems, which highlighted the need for a shared operational language and better cross-functional communication structures. Limited access to complete job card data due to confidentiality constraints also restricted quantitative analysis. However, navigating these challenges improved our ability to synthesize human-centered insights with operational data. This phase of the project reshaped my understanding of engineering as a strategic enabler of performance, not a support function. Without reliable infrastructure, clinical excellence is impossible, regardless of staff competence or strategic ambition. Evaluating the broader operations environment revealed that live healthcare functions within a volatile and resource-constrained ecosystem. Through pestle analysis, several external forces emerged as critical. Politically, load shedding creates reliance on generators, increasing diesel cost, accelerating equipment degradation, and complicating maintenance cycles. This underscored the need to design operations for resilience, not efficiency alone. Economically, constrained private healthcare funding restricts investment in highly skilled technicians' preventative maintenance. Short-term cost control over forces reactive maintenance cycles, increasing long-term total cost of ownership, reducing asset lifespan. Technology, partial digitalization, limits predictive maintenance capabilities. Fragmented system prevents real-time performance visibility, reinforcing operational blind spots. Legally and ethically, infrastructure compliance and safety regulations positions engineering reliability as a non-negotiable requirement rather than a discretionary cost. This analysis helped me understand that operational effectiveness cannot be separated from context. Strategy must respond to environmental constraints, capacity limits, and systemic fragility. Ultimately, I realized that operational performance is shaped not only by internal capability, but by the organization's ability to weather contextual volatility. One of the most valuable aspects of the assignment was translating academic frameworks into real-world diagnostics. Lean and TPS helped identify waste in waiting times, duplicated processes, and uneven work distribution. Queuing theory explained backlog amplifications when technicians' utilization approaches saturation, highlighting that staffing shortages are system-level constraints, not HR issues. Theory of constraints confirmed that technician availability was the dominant bottleneck shaping throughput. Life cycle costing revealed how positioning repairs accelerates asset degradation and capital expenditure. Reliability-centered maintenance and TPN distinguish proactive versus reactive maintenance cultures. ServQual reframed engineering as a driver of internal customer experience, not merely a technical service. Through integration, rather than isolated application, I began to appreciate operations management as a multi-layer discipline that balances flow, reliability, capacity, cost, and value creation. This was also where Drucker's 5 questions served as a strategic anchor. Asking who is our customers revealed a layer of dependency across clinicians, managers, patients, and regulators, each valuing reliability differently. Asking what is our plan underscored the need for shared metrics across engineering, HR, and procurement rather than siloed performance definitions. Overall, theory shifted from abstract knowledge to a toolkit for diagnosing systemic failure and enabling resilient healthcare operations. This assignment significantly shaped my personal and professional growth. I strengthened my ability to analyze operational data, think systemically, and translate insights into practical recommendations. My confidence in using frameworks to inform decision making grew substantially. I also experienced meaningful growth in my leadership identity. I usually gravitated towards coordination roles, ensuring clarity, structure, and delivery. But through group dynamics, I learned that leadership is not about driving activity, it's about enabling contribution. I developed greater awareness of psychological safety, active listening, and inclusion facilitation. Stepping back at the right moments allowed quieter team members to contribute and enrich the quality of outcomes. This experience reframed HR in my mind. Rather than being administrative, HR is a strategic enabler of operational capability, responsible for talent pipelines, capability systems, and cultures that support reliability. If I were to approach a future project differently, I would introduce a shared data taxonomy early on to align technical and managerial stakeholders. This would reduce miscommunication, accelerate alignment, and improve analytical precision. In conclusion, this assignment transformed my understanding of operational effectiveness. It revealed that operational reliability is a strategic capability shaped by the intersection of infrastructure, people, culture, and systems, not merely processes. It deepened my appreciation for the contextual fragility of South Africa healthcare and the need for proactive, resilient operational strategies. More importantly, it shifted my professional identity towards system-level leadership. I now see operations not as a back-end function, but as a core driver of clinical excellence, competitiveness, and organizational sustainability. Going forward, I will apply these insights to build workforce strategies, leadership capabilities, and cultures that support long-term operational resilience. so much for taking the time to listen to my reflection.